Welcome to BTEC Revision. In today's lesson, we're looking at shear loading. By the end, we should be able to calculate the shear loads of stress and strain. Let's start by looking at the keyword shear force. Shear force is a force that involves cutting a material. As you can see in the picture below, we have two forces in opposite directions, and this is going to shear or cut this material, and that's what the shear forces involve. And as you can see here, we have the shear stress, which is equal to shear force divided by shear area. And this is similar to what we looked at last lesson. Stress is force over area, which has the same unit, pascals. Force is newtons, area is meters squared. The only difference here is that we have a shear force instead of a direct force. We can take tau to be shear stress, and shear force can be F, and shear area can be represented by the symbol A, lowercase tau, to represent shear area. Now let's look at an example. We have a rectangular steel plate with dimensions 100 by 200 millimeters, and it's subjected to a shear force of 20 kilonewtons. We're going to calculate the maximum shear stress in the steel plate. So we'll use our equation, shear stress equals force divided by area, and that is equal to 20 kilonewtons. So that's 20 times 10 to the power of 3, and divided by the area. The area is 100 millimeters, 10 to the power of minus 3, times 200 times 10 to the power of minus 3. Because we are dealing with a rectangular steel plate, so that is the length times the breadth. And if we work that out, we should get an answer of 10 to the power of 6 pascals, or 1 megapascal. The next part is looking at shear strain. This is equal to the extension divided by the length. And we can represent shear strain by the symbol gamma, E for extension, and L for length. The units are for extension meters, and length is also meters, and therefore shear strain is dimensionless because meter divided by meter has no unit. Now let's look at an example question. Here we have a rod that has a shear strain of 5 and an original length of 2 meters. Calculate the extension in the length of the wire. So we will take this equation and rearrange for extension. So we will have to multiply both sides by length, and that will give us gamma times length equals extension. Plugging in our values, our gamma, which is our shear strain, is 5, multiplied by the original length is 2, so the extension is going to be 10 meters. Pause the video here and attempt this exam question. This nail is considered to be in something called a double shear. And to solve this type of problem, we need to consider either half the load is acting on a single shear area, or the whole load acting over 2 shear areas. Looking at either method, firstly we'll have to calculate the area, which is pi r squared. And that's equal to pi times 1 millimeter squared. So that's equal to pi times 10 to the power of minus 6 meters squared. Using the first method, shear stress is equal to shear force over shear area, which is equal to half the force, so that's 1000 newtons, divided by the area, which is pi times 10 to the power of minus 6. And that gives us a value of 318.3 megapascals. Using the second method, we can write the shear stress equals force divided by area, shear force over shear area, and that's 2000 newtons of force divided by double the area, so that's 2 pi times 10 to the power of minus 6, and we will get the same answer, which is 318.3 megapascals. And that's the end of the lesson. If you'd like to boost your grades, try some quiz questions at btechrevision.com. See you next lesson.